Explain construction of induction cup relay. So the figure of the induction cup type relay is shown in the slide like this. So this is the iron core, and we have 4 poles of the core here, and the rotor part is connected like this in between the air gap of the stator. So the outermost stationary part of the structure is called the stator or the iron core. The stator core is made up of laminated silicon steel to reduce the eddy current losses. The induction cup relay's working is similar to the induction motor only. The copper wire coils are wound around the stator poles, which acts as the electromagnet when the current flows through them. In the gap between the 4 poles here, pole 1, 2, 3 and pole 2N pole and 2S poles are there. The wound rotor, this is the wound rotor placed in the stator poles here, which acts as the electromagnet when the current flows through them. In the gap between the 4 poles, a rotating cylindrical part is placed, which is known as the rotor cup. Here it is known as the rotor cup. The rotor cup is the lightweight and is made up of non-magnetic conducting material like aluminum or copper. Inside the hollow rotor cup, there is a fixed iron piece called the stationary iron core. Here it is pointed with this stationary iron core. This internal stationary core is made up of again laminated iron, and its purpose is to decrease the air gap and strengthen the magnetic field around. Also you can visualize this uniform air gap is there, so the flux set up in the air gap is naturally sinusoidal or so nearly sinusoidal, or the pure sinusoidal waveform. The rotor cup is attached to the spindle or say shaft, which carries a moving contact. Here you can visualize this. This is the moving contact. When the relay operates, the cup rotates and causing the moving contact to touch the fixed contact like this. This is the moving contact and touches like this, which completes the trip circuit. A backstop is provided to prevent the moving contact from the moving too far backward from its initial position, because backstop is needed, otherwise the moving contact in the backward direction can go randomly at some places. The controlling torque is provided with the help of spring or say controlling springs. The operating torque is given to the shaft when the current flows through it. Damping torque is accordingly in the same direction. So damping and controlling torque both are controlling the deflections and damp out the oscillations in this case. So this is the basic construction of induction cup relay.